The problem given wants us to find a range of a linear transformation described as seen over here. Geometrically and a vector equation needs to be provided. In order to do that, we need to first turn our linear transformation, again as shown here, into a matrix. You turn a linear transformation into a matrix by pulling away the coefficients from the linear transformation and simply putting them in matrix form. As we see here, there is no x2. That simply means that for our x2 in the matrix, we put down a 0. When doing a linear transformation, the way to find the range of the actual transformation is to find a basis of the column space of A. In order to find the basis of a column space of A, we must reduce the matrix into RREF, or at least until we can figure out the amount of pivot points and where the pivot points are. Once we have found the pivot points, we will then take the original columns that the pivot's located in and put them together in order to form the basis of the column space, which will be the range of the transformation. The first step is to start putting the matrix into RREF form. So we took row 1 and we divided it by 4 in order to get a 1 in the first position over here. Next, we took row 2 and we added -2 row 1 in order to get a 0 beneath the 1. And we took row 3 and we added -6 row 1 in order to also get a 0 beneath the 1. We then multiplied row 2 by 2 in order to get a 1 in the second row, the second position. We then followed by adding 6 row 2 to row 3, and this allowed us to figure out the amount of pivots we had. Again, after simply dividing row 3 by 24, we get a 1 in the bottom of row 3, and that allows us to find our 3 pivot points. Once we have our 3 pivot points, we now have a basis for the column space of A. Recall again that these columns are represented by the original location of these pivots, seen in the first, second, and third column of the matrix, which is a 3 by 4 matrix, again over here. So once again, our first, second, and third column are the ones we are putting in the basis. The basis is described over here. As for a vector equation, the range of this transformation can be writing as one constant times the first element of the basis, a constant times the second element of the basis, and then also a constant times the third element of the basis. Those summed together will give the range of t of x. To describe it geometrically, we know that the basis happens to have 3 vectors, and we are currently in R4, which makes this a hyperplane inside of R4. So that is the geometric description of the transformations range.